In our last video, we're going to take a look at identifying the type of variation, whether direct or inverse, as well as combined variation. So before I go through this process, we're going to jump back to this page and take a look at basically solving the literal equation for k, the constant. So when we solved for k, we divided both sides by x. So when you look at a table of values, if the quotient, y over x, is constant, always the same, we have a constant of variation for a direct variation equation. Looking at the inverse variation, when we solve this equation for k, we multiplied both sides by x. So if the product of the two terms in the table is always the same, we have a constant of variation for an inverse variation question. All right, jumping back to our table, I've got the steps listed off to the side here. You can do these steps in either order, but as I'm looking through, I'm noticing the product is the same. And when the product is the same, we have a constant for an inverse variation. Of course, if the product and the quotient are not constant, then it would not be direct or inverse. And finally, our combined variation. So our combined variation equation is y equals kx over z. We've got the volume varying. So volume is our y. K is still our constant. Varies inversely as the pressure. So that's what's going in our denominator. And directly as the temperature. So remember, direct variation is when you're multiplying by a constant of variation. Inverse is when you're dividing by the variable. Substituting what we know. Sorry, sometimes I forget to show you the steps. So we're kind of on step 3. We're going to substitute what we know. We know the volume is 20. The temperature is 320. And the pressure was 1. Obviously, divided by 1 doesn't change anything. Dividing both sides by 320 to solve for k. I like using fractions, so I would not punch this in my calculator. We've got 3 over 32, which simplifies to 1/16. So our volume is 1/16 the temperature divided by the pressure. Typically, we don't have a fraction within a fraction, and since this is in the denominator, you can just move it to the actual denominator and have t over 16p. Answering the question, what is the pressure if it's compressed to a volume of 15 and heated to 330? All right, so to solve this equation in the simplest manner possible, we want to solve for p. So I'm going to multiply both sides by p to get it out of the denominator and divide both sides by 15. So again, I would not just punch this into my calculator. Here's how I use my number sense to simplify this and get my answer as a fraction. I knew 330 is 3 times 110, which is 11 times 10, and 10 is 2 times 5. So I write it as a product of primes. 16 is 2 to the 4th power, and 15 is 3 times 5. So then I cancel my common factors, and I'm left with 11 over 2 cubed, or 8. So 11 eighths, and the pressure is in ATM, the units. And your U-try problems.